Hello, I welcome you to the next video on microwave testing. This is a method to non-destructively test parts made from glass fiber reinforced plastic and other non-conducting material. If you want to learn about the basics of this method, then you are right here. We have already seen what happens when we use a handheld microwave test instrument. The air point, the materials point, and the defect hook with more or less spirals at its root. Here we see these elements again. When we held the handheld instrument in air, we see the air point. When we place it on the material, we see the materials point. And then we see the hook with the spirals at the root when we slide it across the hidden defect. In this case, the material is the section of the glass fiber reinforced plastic leaf spring. We saw that on the use scale, the deflection of the defect signal was very small. Therefore, I have switched the oscilloscope to a more sensitive display and to the storage mode. Now I slide again across the hidden defect. And we see the signal more clearly. Having recalled this to our mind, we will now discuss what happens when the defects are at different depths below the surface of the material. Therefore, first let's look to a principal view. We see here the starting situation, the transmit-receive test head with the antenna, the radiated signal in red, and the reflected signals from the top and from the bottom of the part in green. Let's assume that the inclusion is outside the radiation beam of the antenna, and so there is no incident and no reflected signal from the inclusion. Then the display remains still at the materials point. This continues when moving the test head until the radiation beam hits the inclusion. Then a new dot is open in the display with a line in the storage mode. Continuing, the ray travel length becomes smaller and the defect signal becomes stronger with a more positive angle. The minimum of the travel length is just reached when the test head is above the inclusion. And when moving the test head further on, the process would go back and the display tends to the materials point again. In this extreme situation, we have the defect point. The angle phi under which the defect point is located is related to the travel length. That means we expect the deeper the inclusion in the material, the more negative is the angle phi of the defect point. And in the following, we will see that that is also confirmed by measurements. This is a plate from polypropylene. It contains 9 artificial defects. These 6 are flat bottom holes, and these 3 are through holes. The plate had been tested from the covered side along the positions of the single defects. This time, a test head using 10 GHz was used and not a test head of 24 GHz as we had used before. Here we see a sketch of the plate with holes of various diameters D from 10 mm to 4 mm and residual wall thicknesses from 4 mm to 0 mm. The definitions of D and T we see here in the left sketch. T equals 0 means through hole. And we see the results, the test results on the right-hand side. The columns have the results with equal diameter, and the rows have the results with equal residual wall thickness. For us, most interesting is the left column, where we have the same diameter, but with varying residual wall thickness, that is, varying travel path. From top to bottom, it becomes smaller, and as we have expected, the angle becomes more positive. Furthermore, of interest is it when we look at the bottom row. Here we see 3 defects with different size and constant residual wall thickness. The angle is constant, but the magnitude of the deflection decreases with defect size. So we can summarize. Microwave testing offers the possibility for a three-dimensional localization of a defect in the transverse direction by looking for the maximum deflection, in the thickness direction for looking for the angle of the defect point in the XY plane. And furthermore, the amplitude of the deflection is a measure for the size of the defect. So far, also for the basics of microwave testing. In further tutorials, we will look for some instrumentation and for evaluation and display methods of microwave testing. And so far for today. Thank you for watching. See you next time. Goodbye.